Hello guys, so in this video we'll do the real-time simulation. Actually we'll not do the real-time simulation, but we'll check this model, it's perfect or not, it is fully designed or not, it fully satisfies the requirements of real-time design or not. Okay, so if you have seen my earlier videos, you have already know some basic things about real-time design, real-time simulation. I will not be able to do the real-time simulation execution because I don't have the simulator right now, but we'll check that this model is good enough for performing in real-time simulator or not. So we know the any MATLAB simulation system model that need to be divided in subsystem. Okay, here we can see two subsystem, one is SC, another one is SM underscore. Okay, and the power guy, it will be outside of any subsystem. Okay, and let's check some. Okay, model configuration. Okay, yeah, we have to run it in fixed step, and we have to give the fixed step size. You can select this solver as depending on your requirements. Stop time we have to give infinitive, and okay, we'll apply it. Then we know in SM subsystem all the computational parts will be there, and in AC subsystem all the input and output parts will be there. Okay, here it is. So this one is the ASM subsystem. You can see here two inputs coming to this subsystem. Those two input must come through a opcom block. It's coming through a opcom block. Okay, as you can see here. And for getting result without connecting CRO, we can get the result by using this operate file. Okay, by using this operate file, we don't need to connect this output port of this. It will automatically save the output in workspace. Not in workspace, actually it will create one file. That file name is myfile.mat. Inside that file there will be one variable, that is opvar. Here you can change all this name. So okay, operate file work same as this two workspace almost. Okay, two workspace, or if we add two file block, then it's same, actually almost same. But operate file and this opcom block, it's only available this opcom block in Opel RT Lab. Okay, if you have installed the Opel RT Lab in your system, then you will be able to get it only this opcom block. All the connection, it must need to connect physically means through connector. We should not use any tag inside this. So let's check. Everything is look like okay. Two input coming here, pulse generator, so we can say it's constant. We are giving a fixed, so maybe we can place it here in this SM block. And AC we are just getting the output. This one is giving input. Is this okay? I think there is maybe problem. Oh, oh, oh. No. These both subsystem are connected, and this input coming to this subsystem is coming through this, and the output we haven't connected it any to this AC subsystem. It's actually constant input coming to this. Maybe we can remove. Okay, yeah. Maybe if we want, we can remove this AC block, AC subsystem. Only two constant input is coming, although they are constant. This one also constant, na? 1e minus 7, 1e minus. Does it? Is it any difference in front of front side 08? It's okay, I think constant value. Okay. While executing this model, it's creating some problem that is stopping the RT lab. We have put these two inputs through outcome block, but why we haven't put these two inputs? These are also input. Pulse time, simulation time, pulse generator period. We'll run the model once. Let's check it's running or not. Okay. So it's running. It's too slow. Slow because of maybe the solver. If we change the solver, maybe we can increase. We can speed up the simulation process. Stop it. It's automatically change or not. 1 two warning it's showing. Let's see. The specific buffer for was too small. During simulation, the buffer size temporarily increased to. In order to generate code, you need to update the buffer size parameter. Yeah. In order to generate codes, we need our the MATLAB model generate C code. Then By doing that, we are able to run this model in RT lab. So we have to do something here, maybe was too small. During simulation, the buffer size was temporarily increased to. So in order to generate code, you need to update the buffer size parameter. Uh, so these two are creating problem. Variable time delay, initial buffer size, maximum delay. 1024, 1024, 1024, and it's giving buffer size. During simulation, the buffer size temporarily increased to 1675264. Wow. We'll try to generate C code. How to generate C code? Code. Some Simulink. Under code generation. In the App tab of Model Tooltip, click on drop down arrow under Code. National Assembly Queries. Code generation, Simulink code. Generate C code. Generic C code. Where it will show the code. Code mapping. No data to display. Generate code and build model. Generate the code. Okay. Let's see we are able to generate the C code or not. If we are not, we will not be able to run this model in RT But yeah, cannot find S function model upright file. S function model must exist as either source file or pre-compiled object file on the MATLAB path. Model validation. Zero or one model built. Okay. Cannot find N function module upright file. S function module must list will Operate file. Saying out this operate file. We'll comment out this. Let's try to generate again. Cannot find s function module s function underscore rtlab underscore com. S function module must exist as either source file or precompiled object. S function underscore rtlab, is it saying about this one? Not sure. Let's try to hmm sorry. This one is connected to one, no? Connect this one. We'll comment out this one also. Let's check. Build summary term model on action. PPT build session. One of one model builds. Zero models already up to date. So we are able to generate the C code. It's showing some warning. This warning. The two workspace block has the save format parameter set to time series. This format is supported only for normal and accelerator mode simulation. No data will be logged for this block. To log this signal in rapid acceleration mode, consider using signal logging. To log this signal in other simulation mode, code generation target, consider changing the save format parameter to structure with time. This one is showing. So let's comment out this also. We don't want any warning. Let's see. Two warning hits still showing. Use fixed buffer size in is not selected when generating GRT code. Simulink will automatically use fixed buffer of the initial buffer size set by user. Code generation result and simulation result may differ. Use fixed buffer size. Showing about this now. Initial buffer size is just saying to use fixed buffer size. We have to click on this. Use fixed buffer size. 8.05. When generating GRT ERT code, Simulink will automatically use fixed buffer of the initial buffer size set by user. Code generation results and simulation results may differ. दोनों अलग अलग आ सकता है. Fixed buffer size. I don't know the result will change or not. Maybe I used fixed buffer size. Okay, let's build again. Okay, we are getting any? No, we are not getting any warning this time for generating C code. Okay, so I think the model is now, I'm not sure, but yeah, I can say 99%. Maybe it will run now because we are able to generate the C code. So this is also very important thing for you guys. You can check your model that you can run the model in MATLAB or not by checking by doing this one, by generating C code. Okay, so for real-time simulation we have to do this one. We have to connect this opcom block and operate file for data this one, and we'll comment out this in real-time simulation. Okay, we have done few changes. I think it does not matter that much. This sample time I have changed, and I haven't checked any other things here because this model was already designed. Yeah, and buffer size we use fixed buffer size for both this delay. Fixed buffer size. Yeah, it's look like it will run. Let's run this model once. It's running 0.2. I think now it's a bit faster or what? It's look like the model is simulating bit faster compared to earlier. Okay guys, so bye bye. I think you got to know something about real-time simulation. You can do that thing is very important. You can generate C code before simulating in reality lab, so you'll get an idea that you'll be able to run it or not. Okay, so bye bye.